Okay, so this is method one in order to solve any type of what's called the stoichiometry problem, which is really anytime you have a chemical reaction and I want to know like how much stuff you need or how much stuff is produced. So anytime I give you a chemical equation, you're going to need to do what's called stoichiometry. So the first one is called a BCA table. Stands for before, change, and after. So like how much stuff you have before the reaction happens, what changes during the reaction, and then how much stuff you have after the reaction. Okay, so what we do is especially when we need to find your like leftovers or your excess, a BCA table can be really helpful. Also, if you end up taking M16C2, this is something we will use in there because sometimes you need to know how much is left over of something. So what we're going to do here is use a BCA table to determine the amounts remaining and produced for the following reaction. I've got this reacting with this to make this plus this. So this is what you do. The first thing you do is write out your balanced equation. Okay, got 2 C2H2, 5 O2s. This makes 4 CO2s and 2 H2Os. Okay, so I gave you these before the reaction occurs. I'm starting with 48 moles of this and 90 moles of this. Now, this does have to be in moles when you are doing your before, change, after equations because things react in mole or molecule ratios. They don't react in mass ratios. So you do have to have moles in order to do this. Now, I didn't start with any of these, so you can assume they're zero. So if I didn't tell you you have something, these are zero. So now what's going to happen? Well, every 2 of these is going to react with 5 of these to make 4 of these and 2 of these. So I'm going to lose these 2 things and I'm going to make these 2 things. So you'll notice I said these 2 are negative and these 2 are positive because they are going to gain or increase in amount. So this one is negative, negative, positive, and positive. Now, by how much are they going to change? Well, this is stoichiometric, or what that means is it is based on a mole ratio. So what we need are these coefficients. This is a 2 to 5 to 4 to 2 ratio. So this one's going to change by minus 2x. This one would be minus 5x because its coefficient is 5. This one will be plus 4x because its coefficient is 4. And this one is plus 2x because its coefficient is 2. So these numbers are right from here. Okay, and notice I have an x there because it's not like it actually changed by 2 moles. It's just that the ratio is 2 to 5 to 4 to 2. So anytime you're filling in the change row, it should be negative for reactants, positive for products, the coefficients, and an x. Now, after is when they have reacted. So it'll be how much you started with, in this case, minus how much you used. So 48 minus 2x. Okay, same thing over here, 90 minus 5x. That's how much I would end up with. Over here, it would be 0 plus 4x. So I'm going to end up with 4x. And over here, I'm going to end up with 2x. Okay, ignore the numbers that I have written in there right now. So the after row is just before plus change. Okay, so 48 minus 2x, 90 minus 5x, 0 plus 4x, and 0 plus 2x. That's how much stuff I'm going to make. That's what your after row should look like. Okay, so this, this, and this. Now, then how do I solve for the actual amounts without the x's? Well, we know one of the reactants is going to be a limiting. One of them is going to end up with 0 left. The other one is going to end up with some left. So if you can't tell, so I've got 48 of these and 90 of these. This is a 2 to 5 ratio. It's kind of hard to do in your head. I need 5/2 as much of this as I have of this. I can tell that I'm going to run out of this one first, but you might not be able to tell that you're going to run out of this one first. So all you have to do is just pick one of these. So 48 minus 2x or 90 minus 5x and set them equal to 0 because one of them is going to end up with none. Okay, so I did this one because I can tell that's the one I'm going to end up with. And I got 90 minus 5x is 0. So that means that x is 18. Okay, then I can plug that x value into this equation, and this equation, and get how much stuff there is at the end of the reaction. There's 12 of these left over, none of this because it was my limiting, 72 over here and 36 over here. That's how much stuff there is after the reaction. Now, I said you could pick either one of these two. What happens if you picked the wrong one? So if I had picked this to be my limiting reactant and I did 48 minus 2x equals 0, I would solve for x and I would get a different number. Let me do the math. No, so it'd be 24. So I would get that x is 24. Now, if you go back and plug in 24 into this one, and this one, you would get that 90 minus 5 times 24 is a negative number. You cannot have a negative amount of something. That's completely impossible. So if you get a negative number, because 90 minus 5 times 24, oops, minus 5 times 24 is negative 30. I can't have negative 30 moles of something. That's impossible. So that means you picked the wrong one. So then erase that, set this one equal to 0 and solve for x, and then plug those back in. So what that means is when I did this reaction with 48 moles of this and 90 moles of this, at the end, I had 12 of this left over, none of this. I made 72 moles of this and 36 moles of that. Okay, so again, this is how I showed, 48 minus 2 times 18 was 12. That's how I got 12. And then again, remember, it's minus the reactants because these we're going to lose some, and plus the products because we are going to make some with the coefficients and an x. And so this can get you all of this information, but again, it does have to be in moles. So if you have grams, you got to convert to moles first. Okay, so why don't you try this one if you're going to do the before change after. I'm starting with 0.0780 moles of this and 0.240 moles of this, same equation. Okay, so hopefully you did this and you were like, okay, 0, 0. This one's going to be minus 2x. This one's going to be minus 5x. This one we're going to make is plus 4x, and this one is plus 2x. Okay, so that's my change row. And then I combine them to make my after row, 0.0780 minus 2x. This one is 0.240 minus 5x. This one is 0 plus 4x, so that's 4x, and this one is 2x. So then in this case, I set this one equal to 0. I just picked one, and I got that x is 0.039. Okay, so this would be 0. I would plug x into this one, and this one, and I get that I have 0.045 moles of this, 0.156 moles of this, and 0.078 moles of this. Notice I didn't get any negative numbers, so that means that you picked the right limiting reactant. This one is going to end up 0. I'm going to run out. If you had picked to do this one and set this equal to 0 and solve for x, you would have gotten a negative number somewhere. So you picked the wrong one. So this one was my limiting reactant in this case.